Hello everyone. Today we are going to see here exact differential equation. A differential equation of the form this mdx plus ndy is equals to 0, where this m and n are functions of x and y variables. It's said to be exact differential equation if it satisfies this condition: del m del y is equals to del n del x. What is this condition here? Partial derivative of m with respect to y is equal to the partial derivative of n with respect to x. Yes, if this condition satisfies for this differential equation, then this differential equation is said to be exact, and its solution is given by, here we have this form of differential equation, right? So what we have to take? We have to take m integration with respect to x, keeping y as a constant variable, plus terms of n, yes, terms of n which are free from variable x, and this integration with respect to y is equal to c. So this is the solution for this exact differential equation, right? So what is the solution? M integration, here we have m integration with respect to x plus integration of terms of n which are free from x, and this integration with respect to y is equal to c. So this is the required solution for exact differential equation. Now let's have a look on some examples. Now here we have given differential equation. We have to find the solution of this. Yes, now question arises, by which method we have to find the solution of any given differential equation? Yes, when we have given differential equation, first we have to try for variable separable form, right? Yes, we can check that here it's not possible to do the variable separation here. Similarly, this is not a homogeneous differential equation, and we can't reduce that is in linear differential equation. Yes, so we have to try this differential equation for exact differential equation. And what is the form of exact differential equation? This is mdx plus ndy is equals to 0, right? So here what is m and n? These are the functions of x and y variables. So we will try to write down in this form. Yes, so we will write here this. Yes, we have write down this differential equation in this form. This is the value of m and this is the n. So we will write m and n here. Yes, now we have to find del m del y and del n del x. Now we have to find partial derivative of m with respect to y. So yes, what is its differentiation with respect to y? We have to find m differentiation with respect to y, keeping x as a constant. So tan y differentiation, this is sec square y minus, this is twice x into y differentiation, this is 1, and this is minus y differentiation 1, right? So we got this is sec square y minus twice x minus 1. Now we will find n differentiation with respect to x, right? So here we have this minus, so x square differentiation, this is twice x minus, this is tan square y is a constant, into x differentiation 1 plus x square y differentiation, this is 0, right? This differentiation with respect to x, so y is a constant, so sec square y is differentiation with respect to x 0. So what is its simplification? This is minus twice x plus tan square y, right? Yes, so we have to check whether we got this two values equal. So yes, now we can check that here we have this sec square y minus 1. So yes, and here we have tan, right? So that we can write this value. We have this identity tan square y plus 1 is equals to, yes, we have this identity. So we got this value here, tan square y minus twice x. Yes. Yes, now we have, this is what we, yes, now we can find here, we got this del m del y is equals to here del n del x, right? And what is its value? This is minus twice x plus tan square y. Yes, we got this both equal. So what we have to write here? Yes, so given differential equation is exact, right? So what is its solution now? Yes, we have to find the solution. Yes, what is its solution? We have to take m integration with respect to x, keeping y as a constant, and here we have to take terms of n, right? Terms of n which are free from x, right? Yes, and this integration with respect to y, right? This integration with respect to y here. So yes, we have to write down m here. What is m? This is complete m here. So we have to write m here. So we will write down m, this integration with respect to x, plus now terms of n free from x. Now we can check that. In this term we have x, in this term we have x. So terms of n which is free from x, this is sec square y, and here we have this minus sign, so here we have to write sec square y, and this is integration with respect to y, right? Now we have to find this integral here, this integration with respect to x. So tan y, this is a constant, so we have x here minus twice y, this is constant, x integration x square by 2, and this is y constant, and this is x here, right? This is this minus and sec square y integration, this is tan y. Yes, this is here we have c, not a 0. Yes, we have this is c here. So yes, now we can simplify. Yes, and this is the required solution. Yes. So similarly, we will solve the next example. Yes, we can check that this is of this form, m dx plus n dy is equals to 0, right? Yes. So what is the value of m here? This is, we will write down m. What is n? Yes. Now we have to find del m del y, m differentiation with respect to y, keeping x as a constant. So yes, here we have y and this is constant, so we will have 1 plus 1 upon x. Y differentiation, this is with respect to y, this is 1. Cos y differentiation, we have this is minus sin y. Okay, so we got here this one. Yes, now we want n differentiation with respect to x. Yes, so what is here with respect to x differentiation? X differentiation 1 plus log x differentiation 1 upon x, and this is this differentiation sin y is a constant, and x differentiation this is 1. So we have here 1 plus 1 upon x minus sin y. Yes, now we can check that both these are equal. So we have to say that given differential equation is exact differential equation, right? Now what is its solution? Solution is given by. So yes, what is its solution? What we have to take? Integration of m, right? With respect to x. So we will write value of m here. This is integration with respect to x plus terms of n which are free from x. So here, yes, we can check that in this n we don't have any term which is free from x, right? So here we have 0 terms, and this is integration with respect to y is equal to c. So yes, we have to find this integration. Now what is here? This is integration with respect to x. That means we have to treat y as a constant. So y outside here, so y as it is 1 integration, this is x, plus 1 upon x integration, this is log x, and cos y, this is a constant, so its integration cos y into x, right? And this is here we have 0. So yes, so we got this is, so this is the required solution. So this is the required solution we have find for this differential equation, right? So yes, we have seen exact differential equation. The differential equation is said to be exact when that equation satisfies this condition, and its solution is given by integration of m with respect to x plus integration of terms of n with respect to y, and that terms are free from x is equal to c. This is the solution of exact differential equation. So yes, that's it for now. Thank you. And if you find this video useful, please subscribe the channel. Thank you and keep watching.